Hello, my compers. This is episode 2 of the Umcp Podcast. And today we're underwater.
Mm-hmm. Yeah, I'm
we have a
dripping
few
so
topics
hard,
here.
I flooded the whole place. Now it's an ocean. The haters said that we'd never make it to episode 2. Like, I had haters calling my phone, messaging me on Discord, emailing me, messaging me on LinkedIn with job offers saying you're never going to just quit and do this because you're never going to make it to episode 2. But here we are.
Yeah, here we are. And also, some people who aren't here, our guests that we promised you all for this episode, we have to admit they aren't present.
Yeah,
But
unfortunately,
we
just due to
figured
scheduling, we weren't able to get them on for this week's episode, but they said they'll for sure be on for next week's episode. Going to be a fun time interviewing.
Yeah.
Remember, they got eighth out of about 80 teams in the NCNA ICPC regionals, so that's pretty cool.
Yeah. It'll be a good talk. So we have a few topics to go through.
Mm-hmm.
Specifically on the code jam. So there was a code jam earlier today, round 1A. This is after the qualifiers. These are the people who qualified. They moved on to this round, and we'll talk about a few questions.
Yeah. I can, let me share my screen so we can go through it together.
Nice.
Got my submission right here. So yeah, why don't we talk about this? So there we go.
Let's go through the question, right, for those who haven't seen it.
So how it works is we're given a list of integers, and we're not so much sorting it, like it's called append sort. Not so much sorting it as more we're like mutating the list so that it looks sorted. So how it works is all you can do is you can only add on digits to the end of numbers. So that's why we're appending digits. So for example, we want it to be strictly increasing. So that means they can't be equal. Nothing can be equal. It has to be always increasing. So for example, 107 and 10. This is just one way to do it. To make this 7 bigger than the 100, you see they appended a 4 and then they appended an 8. You could have appended 2 zeros, you could have appended 2 1s, you could have appended 2 9s, whatever. And then for this next one, they saw that to make the 10 greater than what is now 748, they had to append a 3 and a 4. You could have appended other things, but the point is, you count the number of appends you had to make. So in this example, you made 4 total appends, and you see down here, your output would be case number 1, 4. So how it was inputted at the very beginning, it tells you how many cases there's going to be, and then for each case, it'll give you n, which is the number of elements, and then it gives you the list. You output the number of appends you need to append sort it, and then so on for the rest of the cases. So what are your thoughts on that question, Abram?
So I'll just say this. Like, it's funny because with the example they give of the 107 and 10, and then the solution they give, which is to add 48 and then to add 34, if you do it like that, assuming you wouldn't have got it.
That was a trick, honestly.
Yeah, you had to make sure that when you're appending numbers, the number is no bigger than it has to be.
Mm-hmm.
Because if it is, then you might end up requiring extra appending on the next number.
Mm-hmm. And you can actually see in my solution,
yeah,
what I actually did is I always did zeros except for one particular case. Mm-hmm. So if you can look here, so how I did it, I kind of did like an inside-out approach, which I feel like honestly works the best when you're doing questions like this, is that first, it's like I started with find appends, where once you give it the 2 numbers, and this is where the bulk of the logic comes in, you give it the 2 numbers and it finds like how many appends you need, and then you call that with append sort, like it goes through the list of numbers and calls that function I just made, and then I have one to format the input, and then finally the actual stuff. So I kind of do this start little and go big approach because it helps me kind of visualize and break down the question. But so what I did is, so find appends, it'll be, so for example, in this one, it would be given 100 as x and y as 7. So first I found the length of them. Some of this might be like a bit tedious or like a bit inefficient or not very elegant, but it worked, is what matters. Like, maybe I didn't
Yeah.
need to store the lengths in a variable, but, whatever works for you, I think is fine. So this is going to return the amount of appends you need for that, and then the digit. So what I realized is that all that really matters is the very last digit. So for example, here, I would put 700. But say you had an example where it was like, let's think of like 25 and 2. So to make it bigger than 25, you could make the 2 into a 26, right? All right, let's think of a better example actually. Let's think of 232 and 2. I could make the 2 into 233, right? So what actually matters is it doesn't matter what that middle number was. I could have 203, 213, 223, 233, 243, 250. It didn't matter. All that really mattered was that last digit. Because let's say I have something underneath it, and let's say it's like 234 or something. That would affect like that one there, because so let's say I made the second number 203. If I made it 203 and the second number is 224, then you see that that I don't actually have to do anything there, right?
Right.
But if for some reason I was like putting in 9s and I made 293, then that's different. Now I do need to add an append when I actually didn't need to. There was a way to do it without appending.
Yeah, true. And I'll even say this. So basically what you're saying is what we care about are the leading numbers. The numbers, we're considering examples where the length, like I see you have variables length 1, length 2. We're considering cases where the length of 2 is less than length 1 or equal to. We only care about the numbers, the digits in the first number that are within the range from 0 to the length of the second number. And then what you're saying is, because everything after that, we can just append whatever we'd like. But the only cases, like here's the thing. We had the same solution. As you can see, there's a certain case where we just say, we're setting the second number to the first number plus 1. And that's because you want to keep the number as small as you can, but still greater than the previous. But then you can run into an issue in the case where every number after the leading numbers are 9s. Because then, if we want to do that number plus 1, we know that the way it works, because every number after the leading number is 9, then we know that adding 1, we're going to have to affect the last leading number, which we're not allowed to do. Because we know that that any leading number can't be changed by the way that we append sorting the list.
Yeah, and so basically what I did is, because I know those middle numbers, just so that to go from 100 to 7 in these two, it could see they put 48. I always put zeros if I could.
Yeah.
That was basically my strategy. Always put zeros if you can, and if you have to, you just do 1 plus the last digit, which is where digit came in. So usually digit is 0, except for this one case. So we can go into it. So how I did it was, first I look at the leading number. So I have this is a bit messy. It was a lot of copy paste. This could definitely be simplified, but it was turning the numbers into string and then accessing element 0, element 1, etc., to get the first digit, second digit, third digit. So I look at the first digit of the previous number. And so if that's less than the first digit of the other number, then all we have to do is to append the second number so that they have the same amount of digits, and that's all the appends you need to do. Because look at 107. That falls into this case. So I'll try zooming in here. So we see that the 1 is less than the 7. So if these were both 3-digit numbers, no matter what those digits are, I know for a fact it's going to be bigger than the 100. So that's why I did whatever the difference is between their lengths. So 3 minus 1, 2. So that means I only need 2 appends there. And then notice how I didn't set the digit. I also broke because you don't need to go beyond there. Once you find out how many digits there are, you don't have to go beyond there. And break is like a bit of a controversial programming practice where a lot of
I like it. And
actual software engineers and programmers don't like it. In
I
terms
think
of
for competitive
competitive programming,
programming,
it's
great.
just so quick to actually type.
Yeah, yeah.
So so yeah. So I found that, and then notice. So when I actually set it, you can see that I have to update the list because the if I kept it at 7, then the 10 I would say, oh, the 10's already bigger than 7. I don't need to do
Mhm.
anything there, and that would be an issue. So you have to actually update the list. So you can see what I do here is I just multiply by 10 to the power of the amount of appends. So you see I needed 2 appends, so I multiply by 100 to make 7 into 700 plus digit, which is setting that last digit that I was talking about, but it's 0 in this case. So moving on. So if that first digit was greater than it, so for example, let's say I had 70 and then the number 5. So I see the 7 is actually greater than the 5. So I see no matter what I do, if they have the same amount of digits, that 770 is going to be bigger than the 5. 70 is going to be bigger than 59, right? So,
Mhm.
but I do know if I add a digit, if I make it a 3-digit number, any 3-digit number is going to be bigger than 70.
Yeah.
So that's why I did the same thing there except plus 1. Boom. Now, when it gets a little complicated is when they start to be equal to each other. So you notice if they're equal to each other, it just goes to the next number. So if I had 259 and 258, it would go 2 and say they're equal, move on. 5, they're equal, move on. Until I got to the very last number. So this is where I could have saved time, um, but this is kind of how I did it. Is that if it's at the last number, so first I check if there are there are kind of two cases here. They could have the same amount of digits, or the previous number could have more digits. Because you see here, I only do it if they have equal digits or if the second number has less digits. So in the case that that the first number has less digits than the second number, you see I don't even go into anything and I just return 0 because it's already bigger, right? So what I do is I check, are the next numbers all 9s? If they aren't all 9s, then that means there is a way where if they had the same amount of digits to make the second number bigger. Like say I have 9999998 and then I have the number 9 or 99.
Yeah.
That last number I could set to a 9 and make it bigger than the previous number.
Yeah, without exactly. You don't even need to add more digits than
Yeah,
the
because
previous.
that's kind of this is one of those
number.
edge cases where it was a bit tricky. Where if you don't do that check, you might end up with one more append than you need. Because you might look at that and say, okay, I need to make them have the same amount of digits plus 1, but there is a way to do it where when they have the same amount of digits. The only time when you can't do it is when all of those remaining digits past the point where they're equal are all equal to 9s. Then you know you have to put that extra digit, which is right here. And the case when where the both lengths are equal, you'll see that all 9s will just stay true, so it just goes straight to the else. And because they're both equal and they need to be strictly increasing, you have to add a digit.
Can you go to the sample? I want to see. Did they give a sample that would? Oh yeah, look at that. They do. So you see in the third test, it goes from 19 to 1.
Mm-hmm.
So that'll be one of the cases here. Because if we go ahead with just saying, oh, we're going with that number plus 1, then we'll end up with 20, which isn't allowed. So that's one of the cases where we have to check that everything after the leading digits is 9, and then we go ahead and just add the more digits than the previous.
Yeah, and this digit part, it's not necessarily for so for example, for the 19 and the 1, I could take out the digit part and it'll still say true. What happens is if there's a number after the 1 is where the digit becomes important. Because if this was 19, 1, and then say 2, then I would say the 19, 1, okay, that needs 1 append. Then I'd look at 1 and 2, and I'd say, oh, that's fine. Like if I just put it as 10, or sorry, let's say 20. No, let's say 15. So let's say it's 19, 1, and 15. If I just said it had 1 append, and then I updated the 1 to a 10, then it would say, well, 15 is greater than 10, you need 0 appends there. When in reality,
exactly,
this had to be, oh, I guess, okay, that only works when this is 18, but you see what I'm trying to say. Like, in reality, you would be skipping some stuff, which is why this digit is important. It's only important for the numbers after it, not exactly for that case.
Yeah. And that's the thing, yeah. If the number was even like 90, then if you hadn't set that to oh no, you're right. I see what you're saying. But there are definitely some cases where it'll break, and I guarantee in the test set they were checking, you
Hmm.
know?
Oh yeah, because that's the thing. I remember we talked about it last episode. If it's an edge case, they're testing it. And
Yeah,
they definitely tested cases like
exactly.
that. Like they would have checked 18.1 and 15. They would have checked that for sure to make sure that you're
Hmm.
updating that one into a 19 what it's supposed to be.
Yeah, totally.
But yeah, you'll notice that you
Okay,
only
do you
need
want
to
to go
do
to the
that.
next one?
Yeah, you only need to the digit only matters when it ends in something that isn't a 9. So if this was 18,
Hmm.
that's when it would have went in here and it would have saw okay, it needs the last digit needs to be a 9 and it would have made it 19. But yeah, we
Hmm.
can look at the second one now. Time. This one didn't
Sure.
attempt.
That's okay. Don't worry about it. We can, okay, we're gonna have to talk about the analysis too, to be honest, because the
Yeah.
analysis is just
Why don't
insane
you
on this
introduce
one.
this one?
Okay, so basically you're given cards. You're given cards, and each card has a prime number on it. So in this example here, it shows that they have divided the cards into two groups, and the way it's a game you have to play. In
Hmm.
this game, once you've been given your deck of cards, you have to split them into two groups such that the first group on the left, the sum of those primes is equal to the product of the primes in the second group. So, and then you also, in the case where there's many different solutions to given a set of primes, you need to look for the one where the sum of the cards on the first group are the highest possible. And here's what I'll say. So I answered this question, and I only had, I think, maybe like 30 minutes left. So I honestly, I just said to myself, I know what I'm about to do is wrong,
Hmm.
but I did the binary. I did every case.
Hmm.
Which, and if you look at the test sets, so let's look at the size of the test sets. Test set one is only up to 10. And when they only test up to 10, you know that you can be nasty and it's still gonna work.
Yeah.
But when we start talking about like test set two, 100 isn't huge, but when you can't do factorial, factorial
Hmm.
100 is is
Is
is not gonna work. And then don't even get me started on
10 to the
10 to the
15.
15, right? So when I was talking about, I wanted to talk about the analysis. The analysis on the test set three is really, really amazing.
Hmm.
And
It's very
basically,
interesting.
it
And it's very
required, in
interesting
my
the amount
opinion,
of
it
people that
required,
figured that out right away.
yeah,
A lot of people did this
it
under an
required, in
hour and
my
a
opinion,
half.
a ton of understanding.
Yeah. One thing I do want to say
Like,
is that this kind of technique of like I'm just gonna go for test set one because I don't have enough time. It's perfect for like Google competitions, but if you look at things like the ICPC, questions like that, like they usually have they don't have separate test sets for each question. They have one test set, so it's
yeah,
all or nothing for those questions. So it's
yeah.
not always gonna be a
And if
viable
they're
strategy.
yeah,
But
if
if
they're
it is
only
something like the
asking one
Google
test set,
competitions, they do this separation into test sets a lot. Then it's
yeah,
very viable for that. Yeah,
right.
let's head over to
Like,
the
and with
analysis.
ICPC, if they're only asking for one test set, you can basically guarantee that that it's not going to be the easy test set.
Yeah.
You're going to need to have a smart solution to the problem.
Okay. So yeah, let's look at kind of how. So for test set one, this is probably just gonna say the like kind of brute force way of doing it because yeah, exactly. It's a 10,
Yeah.
so we can just yeah, they're just gonna go through all scenarios, and you get the 2 to the n.
Yeah,
Yeah,
that's exactly what I did. Yeah, two to the end.
2 to the n times n.
Yeah.
That's not gonna work for 10 to the 15 when that's 10 to the
Mm.
15. But yeah. So the total number of cards is at most 100. So now that like 2 to the 100 times 100 is going to be kind of crazy.
Yeah. Yeah.
But so yeah. So this is where they start talking about an upper limit. So this is an interesting analysis where it talks about where this is very like specific to the question. You would normally think like, "Oh wow, 10 to the 15 like it must be this like brilliant like ON solution, something like that."
Well, yeah, and that's the thing with 10 to the 15, even big O of n is just not going to happen. There's no
Yeah.
way. Like
Even that. Yeah, that's
you
true. Yeah.
literally need like, I mean, obviously it can't be done in constant time. So you
Yeah.
need log n, and even log n, I kind of question whether or not it
Yeah.
would actually work. So
Like
I
log
think
log of that is what, 15 times log to the 10. Okay, that's not that bad.
it's just yeah. I mean, the thing is, it's just a huge amount of work to be done.
Well,
So
actually,
so
wait,
basically,
log of 10 to the 15 isn't that bad, right? Like,
no, you're
log of
right.
10
Logs to
is
10.
2 to the 4 point something, and then 4 point something times 15. That's actually hella quick.
No, you're right. Log is basically good. Log is basically good enough,
Yeah.
and especially the only thing less than log would be constant time, and you can guarantee that constant time. There's no constant time solution. Like
Well,
that's
actually,
just
I think in a way this was constant time.
it's not though because you still
It was like 30,000 or less, right?
okay. Well, no, it's interesting. It's constant time, but also not because if the sum is small, then we don't actually go through the full 30,000 because then we start
Right.
talking about negative sums.
Yeah,
So
yeah, we'll
you're
get to
right.
that. We'll get to that though.
I would
But
okay, yeah, yeah, yeah.
yeah, the point is like this is the funny thing is like you would think like maybe there's like a formula you could plug in, like once you plug in the numbers you could do some like quick formula and then like find it out. But that wasn't the case there. This was like such a, I wouldn't even say it was like a dynamic answer. It was more of like a static answer, Like you found an estimate for how high, or like an estimate for how many loops you need to do, and then you
Yeah.
found the solution from there. So like we can look at what it says here. So yeah, it's basically saying if we did all partitions for n equals 100, like it would be too hard. So now let's start talking about like what's the maximum sums going to be? Like what's the maximum that we can expect and work from there? So in this one it says like the upper limit for the sum of the first group of numbers is 49,900,
Hmm.
because that would be if you look back here, I guess we kind of skipped over it.
Yeah. So basically, the highest prime that we can look at is
Yeah.
499, and the most the case where we have since we only have up to 100 total, we know
So
that we
100
can't have
times
any more than 100
499.
times 499.
Yeah, so that's
So
going to
we're
be the
left with
maximum sum for the left pile.
right. It's 50,000 about that.
Yeah. And so that means we can't have more than 50 numbers in the second group. So it's kind of saying that say two we had in the second group, 2 to the 16 is bigger than 49,000. So if we did 2 to the 15, that's going to be less than 49,000.
Mm,
So if we have any more than 50 numbers, like if that product is more than the sum, then it's not possible, right?
yeah.
And the reason why we use 2 is because that's the lowest prime number. So we're saying if we have, so look at this maximum sum we have, this let's just call it 50,000. So we have this 50,000. If to make that possible, there's no way we can have more than 50 numbers, because even if we have 2 to the 16, that product
Yeah.
is already going to be too high. So think about 2 to the 15 times 3, like that's going to be even higher, right? So
Yeah.
there's no way to make those two piles equal if we have more than 15 cards in the right pile. That's
Yeah.
like that's a big conclusion that they use in this question,
And
and
that's
it's
the thing.
actually really interesting.
You'll see in this analysis that once you make that conclusion, you can just go back to your brute force.
Mm-hmm.
You can brute force it with this new knowledge that we only need to test 50,000 cases.
Yeah,
We,
and
we
that's
don't need to go through.
kind of what I want to go back to saying is that it's kind of amazing. You would expect that like the solution to this is not going to be brute force at all, when in reality it's just brute force with some exceptions, or
That's the
brute
thing.
force just cut down on possibilities.
Even for the third group, that's still the case, isn't it?
Yeah, exactly. That's what I
Yeah.
was saying.
So
And I
like,
think
yeah, but
something that kind of hints at that is the fact that they limited the amount of prime numbers.
mm,
Like they weren't saying, because if it was like just this conjecture you need to know about prime numbers, it wouldn't matter the amount of prime numbers, right? And you could do it in like this like really interesting super math based solution,
yeah,
but in reality it's like they're like, this isn't something like that. You can do this just from like figuring it out from the question, and once you have these upper estimates, you can go back to your brute forcing computer
yeah,
science style.
yeah,
So yeah. So what they did there is, so they found that out. And so I actually didn't read how they did it in here, but
Yeah, so
we can just kind of explain like how it's done.
sure. Basically, so the way it starts is if you can calculate the sum of all cards in your deck, since we know that the what is it? We use that number 50,000 and we descend from the sum down to the sum minus 50,000 because we know that any solution that exists will be in that range.
Mm-hmm.
So if you, and also here's another thing, you don't need to do this, but if you start from the top, meaning you start at sum and you work your way down, the moment you find a solution, you can guarantee that that is the single highest solution possible. So you can stop right there.
Exactly. Yeah, and
And
I
even in
forgot to
worst
mention is
case,
that in this you're outputting the highest value of each pile where they're both equal,
right. Yeah,
which is why you
exactly.
start from the top and work your way down 30,000 or n, whichever is less.
Mm-hmm.
So with that
Yeah,
solution, it's pretty much what they explain here. And then in the final test set where n could be up to the 10 to the 15, that's where they did that same estimation we had of the before it was like 2 to the 15, now it's 2 to the 60 from the same like pretty much the same calculation, right? 4.99 times 10 to the 17. That's the maximum sum because 499 times 10 to the 15 cards is the same as this. So that's the highest
yeah.
number you can have on the left. And so that means even if they were all twos, if you had more, or if you had at like 60 or more cards in the right pile, there would be no way to do it.
Yeah.
So it worked on how we're doing this. We're brute forcing, but we're limiting the amount of cards that you can put on the right. So
And yeah, the reason we're able
instead
to
of the
do
amount of
this,
cards in a normal brute force of saying there could be 10 to the 15 cards in the right pile, I'm going to check all of them. We limited 10 to the 15 all the way down to 60. So this really is like
yeah. And this
almost
is an example.
like a log n
This is an upper
kind of
bound.
solution.
Mm-hmm. Like I think what's really interesting about this question is they didn't actually optimize the algorithm, but they
Exactly.
optimized
It's
the
like they
range.
just cut out
So they
possibilities.
had,
Oh,
yeah.
my internet connection's
It
unstable.
was really interesting.
Yeah, I really enjoyed that though. So yeah.
Yeah, that was good.
Um.
Do you want to talk about our next topic?
Yeah. So we can kind of go from there. So let's head back to the main meeting room. So let's talk about the different thing is on the what's interesting about Google Code Jams is you can actually look at every single participant's submissions, like every single one of their submissions. So it's very interesting. You can
Yeah.
see like if they got a wrong answer error, you can see the submission for that, and then you can see the submission of the next one where they fixed it, and it also shows you which languages they used. Now, if you've done like a bit of a dive into competitive programming, you'll see that C++ is what is pretty much used on the highest levels of competition everywhere. Every single like high level uh, programmer will use C++ for the highest level specifically. Because you'll even see in this one, for example,
Mm-hmm.
there were people who used Java, people who used Python, like not as much. There's still like overwhelmingly C++. But the reason
Yeah.
for that is because C++ is just a faster language, like on the low end, where there are some questions where they were even in past like Google Kickstarters, I think, like people have linked questions where they show like try doing this one in Python, now try doing it in C++, and you'll see that you can solve it in C++ no problem, but in Python, for example, you'll get a time exceeded error, and it's just a difference of the languages. So to be prepared for that, if you're aiming for
Interesting.
first place in every competition, that's why people like so many people are like, I'm just going to use C++ because if I know C++ is guaranteed to work for everything, but other languages aren't necessarily guaranteed to work for everything, well then I'm going to just use C++ all the way. But if you're
Mm.
someone who like started learning Java or started learning Python, that's going to be good enough for you for like a long time. Like there was one person who did all these questions in Java. There's someone who did
Yeah.
all these questions in Python. There's probably people who did all these questions in other languages too. It's just that
Yeah, that's
like
the
you
thing.
see
Literally,
that all the
number
top
40
programmers
in the
use C++
world.
and there are advantages to it. But if you are using those advantages and but you're getting disadvantaged because of experience. It's no longer worth it, I feel.
Yeah. Oh yeah, absolutely. I think honestly, pick the language that you feel most comfortable with.
Mm-hmm.
I think that it's important in terms of practice to expand the number of languages you know, because definitely there's certain cases where you might want Java because it's so nice in terms of making objects, or maybe you want to use Python because you feel, it's like, because Python is good for, I felt like the Google questions they give are like perfect Python questions. They're just like no objects remotely required. Just go through it with loops and maybe some arrays and you're good, But definitely as questions get more complicated, I feel like objects become more, because here's the thing, Google Code Jam is a short contest. It's 2 hours and 30 minutes. And I feel like when they give you that much time, they're basically saying, technically, you can do this in an hour and a half, or maybe an hour and 15 minutes. Like if you know exactly what you're doing. And I don't think they want you to write a lot of code. If you look at any of the top answers, there's not much code. There's a lot of template, but there's not much code because depending on which language you pick, you can sneak through it a little bit.
Yeah, and the thing is, most of these solutions, they don't want you to have like 4 nested loops and all this stuff. Like that's why they make these test cases so large, is that they want you to have this like simple, elegant solution.
Right.
And
Exactly.
so the thing with that is like, if you're trying to force yourself to do C++, don't do it in competitions. Do it in practice to get used to
Yeah.
it. Only pull it out when you feel like C++ is like second nature to you, because otherwise you're going to spend so much time like, okay, how do I convert this to a string? How do I convert this to an integer? How do I typecast this? How do I do this
hmm
function? How do I make this variable? How do I make this array? How do I initialize this? What's the function for this?
Literally every issue I had with this code jam was related to Python types,
Mm-hmm.
honestly, because I didn't realize, like in terms of string multiplication, I didn't even know that was a thing. So I assumed because the number was multiplying that it was a number and not a string. And I
Right.
was using it as my, my next number in the sequence. And I'm talking about the appending question. Like,
Yeah.
so I was getting huge numbers because it was like, this string of size 3, but times 10 to the power of 3. So when it comes to when it comes to like numbers, that would just mean, okay, this number is times 1,000. But when I'm multiplying a string, it means that that string is now 1,000 times as long, and the number is like 10 to the thousands of times as long.
Exactly, right. Yeah, and so that's the thing is you should definitely use what language is most comfortable to you. If you're at World Finals for Google Code Jam, then maybe yeah, you do absolutely need to use C++. But for like these stages, and especially if you
Yeah.
if you don't know C++, then you're probably like just kind of getting into coding, or maybe you are good, like really good at programming, but you're just getting into competitive programming. Stick to what you're good at. If C++ has any disadvantages to you personally because of lack of experience, then it's not going to be more viable than a language that you're more experienced in. But
Yeah.
it definitely is good to pick up on for the later stages of competition, like World Finals for somewhere. But and the
hmm
other thing is also, every competition kind of has different rules and different ways they do things. So for Google, uh they don't guarantee that there will be a possible solution for every single language. So it's most likely that C++ is going to be the only one that guarantees that. But there are other competitions, like for example ICPC. For every stage of their competition, I believe it is, at least for regionals I saw, is that solutions are guaranteed in C++ and in Java.
Mm-hmm.
So think about a competition like that. You don't ever need to know any C++ at all. You can do it all in Java because it's guaranteed that it'll work in Java as well. So I think comfort is always going to be way more important than it's just like a ranked a better language or it's faster language, whatever. It's only going to be that good if you are also good at it. You like that
True. No.
ABBA?
Yeah. I actually By the way, is your screen completely green or is that just me?
I think that's just you.
Oh, okay. Like no, it's not just completely green, but it's like Mostly green.
Yeah, I think that's you.
All right, what was our next topic?
Let's talk about our favorite IDEs. Let's talk about something fun.
Sure, sure.
So, what's your favorite?
Okay, so I think we should actually divide this. Can we divide this into two groups?
Okay.
Can we divide this into specifically for Java? Because I know that Java's used a lot at U of M, and this is a U of M podcast. Let's talk about our favorite Java IDE and then our
What's
favorite
our favorite
general
JDE
purpose.
and IDE?
Yeah, exactly. Okay. Okay, I'm gonna be real right now.
Mm-hmm.
I am literally unhappy with every Java IDE I've ever used. Here's why. I I think okay, so I learned Java on an IDE called BlueJ. Okay?
Woo!
Okay.
Spoiler alert, that is my favorite.
Okay, now let me just say something. This is not a good IDE. That's just fact. There's many problems. Let me talk about a few of the problems. There's also a few upsides. One problem is that when you type in code, the color coding or like the coordination and like the
Mm-hmm.
it is always broken for me. Always.
It breaks a lot, but that's my favorite part of it.
No, that is not good.
I won't
So,
lie, sometimes the whole thing will be broken, everything's like white and like weirdly indented. I have to sometimes it won't even run because of that. I have to close the entire IDE and open it back up just so I can keep coding.
yes. Yes. Second of
Still
all,
my favorite
okay,
though.
I will say what's interesting about this IDE. It gives you a visual, which is
Mm-hmm.
kind of cool. Like it shows you if you're implementing an interface, it'll show you that. If you're extending a parent class, it'll show you that
Mm-hmm.
on all like visually, which is cool. But I hate it still. And another issue with it is when you're typing in input, you have to go line by line. You can't actually just enter everything in at once. But you
Yeah, if you want
can
to do it efficiently, you're forced to use it like a text file.
yeah, you need to use a text file because if you're one of those people who just likes to type in like copy and paste the input, can't be done. Okay,
Nope.
and then I'll talk about another Java development
I mean,
environment.
you can do a little workaround by like writing your Java in there and then just running it in your terminal. But
Yep,
yeah.
that works too. Yeah. Okay, another thing. So Visual Studio Code for Java. Okay, you have to
Mm-hmm.
use the. I think you need an extension to actually to. What I'm talking about
Yeah.
is not using terminal, but using the Visual Studio like run button, that kind of thing.
Like
There's
their
ups.
built-in terminal.
Yes, there's
Yeah.
upsides which I like, which are the fact that I mean you can just copy paste input, which I think is nice. You
Mm-hmm.
can the color coding works, like everything looks good.
I mean, it
The
doesn't color the
downside is
blocks, which I feel like no other JDE is doing, and I think that's
yeah,
where BlueJ is king, and that's where it kind of takes the
true,
cake for me. But
true.
it makes it
Uh,
look like you're coding in Scratch, like. Anyways,
yeah.
you can
The thing is,
continue.
I would also say that wait, are you broken up? You're frozen for me.
Oh, yeah, you kind of lagged out a bit there, but I think it's good now.
Oh, my bad, my bad. Okay, but yeah, so like Visual Studio Code, I will say a downside is I'm literally permanently getting issues in terms of taking an input. Like I remember in the course 2150, I think it was 20, maybe 2140, I wrote this whole project and basically there was a problem. It wasn't taking an input correctly on their end. And I was like, how is that possible? And the answer was Visual Studio Code, the way it compiles your Java is very weird. So you can have something in the input file, but because the way it's running it isn't from the current directory, it's from like the root directory, it's not actually able to access the input file unless you give the exact path. You can't just give like a relative path. And if you do, then you need to add on like some more code to say like, here's the current path and here's the like extension to that path. So it's just complicated, okay? So what is my favorite Java development environment? Honestly, I have none. I hate them all.
Well, it might be
But
IntelliJ. We're gonna try that out, I think.
yeah, yeah.
That's
But
what
then I'll
Lucas R
say
from
my favorite.
Argentina, 41st in this Google Code Jam, used.
He inspired us.
Yeah, he was the only one up there we saw using Java. He completed it all in
Yeah.
like he originally like completed it all in like an hour and a half or like an hour 50, but then he didn't get the hidden
Yeah.
test set, so he had to go back and like change a couple things, and he finished it in like
Mhm.
just over 2 hours.
Yeah. He clutched. Okay, I
Yeah.
will say though, I think my favorite IDE is just Visual Studio Code, but not for Java. For everything else, I love it.
Yeah, that is such a weird thing though. Like that, I can see how that's really annoying. That's
Yeah.
kind of funny. Yeah,
Mhm.
honestly, I'm kind of like a one-trick pony. I don't even really use many different IDs or have used different IDs, so it's probably just gonna be VS Code for me.
Okay,
Like
I
that's
thought you were
just
gonna
what I
go
use
with
for
like
everything.
LC. I thought you were gonna go with LC3 tools as your favorite IDE.
Oh yeah, that I love that.
Yeah, there's never any problems with that.
Yeah,
It never
ever,
like
ever.
free. It never freezes and crashes.
Not once. I don't even know what that word means when you're talking about LC3. The
Yeah.
C in LC3 stands for crash, and the L stands
Yeah.
for
Never.
uh, lots,
Yeah.
lots of
Oh, lots of crashes. Three.
three because they had two and one.
Yeah. Yeah.
Oh
But two and one didn't crash enough, so they had to keep
yeah,
on
they had to
extending.
really pump it up with LC3. Oh
All
my
right.
god.
That's funny.
Yeah, moving on
Okay,
from
so
IDE, something that's kind of like on the same topic as plugins. I
mm,
noticed so the guy we mentioned, Lucas from Argentina, he had in his he commented in his code that he used C Helper, which is a plugin for
Java.
IntelliJ, and it
Oh,
helped him. It's basically for coding competitions because it helps with with testing, and like it has this nice framework that you can use, and it generates it so easily. And if you look at the code he did versus the code that was generated, it was probably like half and half, honestly,
mm,
which is really really nice. And I think one thing important for coding competitions is come prepared for it. If you want to like win, you need to come prepared. You can't just come, open up your IDE, open up the problems, and like, all right, let's go. You need to have like templates ready, things that are ready to take an input, ready to like parse through the strings. You need to have functions of things you'll expect. Like so, for example, inputting a string of numbers separated by spaces and you needing to turn that into an array or a list of some sort, you're gonna need that in like almost every question. So you might
yeah.
as well have a function that'll do that like just ready. And you should have like for things like Google code jams and things like that, it's actually really helpful because they kind of have the same like format to all their questions where the output is always going to say case number blank and then the answer, case number blank and then the answer, and the input's always going to be first it's going to be one number inputting the number of cases and then the each case inputs. So you can actually have
Mm.
as like a pre-written template for each of your questions an output that says like case number blank and then the answer and then just kind of fill in the blanks from there. I think that
Yeah,
saves a
plugins are
lot
super
of time.
helpful. I think that in terms of like reaching the top is when we get onto the topic of picking C++ or picking a beautiful plugin because you need to be certain that like you don't want to waste time on anything you could have prepared earlier. You
Mm-hmm.
know, everything you can prepare earlier should be prepared earlier.
Mm-hmm. Yeah, I think that's great, and that's why plugins or even just writing some things on your own, or even just having like a cheat sheet of functions you're probably going to need to use is going to be important.
Yeah, totally. It's not even cheating, guys. It's actually just strategy.
It's just strategy. I mean, there are some competitions that's not possible for, where I think all these online ones allow you to do that. But like for example, ICPC used to be in person, I'm pretty sure, so obviously you couldn't have that. But they did have rules where you could have like you could have stuff printed out on a piece of paper if you needed to. Like you like I think at World Finals you were allowed to have like one full sheet of paper with like printed functions or printed notes, whatever you need. But
Hmm.
having stuff prepared for these I think, but for all the Google ones, they're always online. They're always like this, where you can come prepared like that, like have your templates ready, have your functions that you might need ready. Some of these solutions, if you look at, like 80% of the code is unused, but it's just there in case they need to use it. So I think that's really important. If you're
Exactly.
aiming for like that number one spot where it comes down to like 10 minutes, 5 minutes, like that's what you need to be doing.
By the way, I have some good news.
Mm-hmm.
I may have just spotted another. Yeah, I just spotted another Java champion.
Oh my goodness.
So if you go to number 35, Fang Zhuan, number 35, an American, he
All right, let's look at it.
all of the solutions, Java. And he's number 35 in the world.
Number 35.
Oh, and his solution is really interesting.
This is beautiful.
I
For
don't
which
know,
one?
for a pen sort, just look at the shape of his solution.
Okay.
It actually kind of looks like mine, to be honest. I did a similar thing.
Okay, so he made a scanner. He used input stream reader, then a buffered reader, and then a
Okay,
scanner.
what is big integer? Do you see this?
Yeah, it's similar to long, except it's like huge.
Oh, okay. Huh.
So what did he do?
I have a feeling he probably did the same thing that we did.
Oh, this is a
Was
pen sort, right? I
yeah,
was
this is
thinking
this
this
is
is the
yeah.
prime one.
No, this is just a pen sort. So he kind of kept it simple. And what's interesting, I feel like he doesn't even have much of template going on.
Yeah.
So this guy, I would suggest, has that raw skill.
I feel like he has this, the scanner thing, these maybe just these two. He probably put in the math.
Oh yeah,
Maybe he has the
there's
math.
for sure a bit
But I think
of
he definitely has this and like this. Like these first three lines and this line are probably always already there.
if you want to see a beautiful solution, go to the prime time. Go to the question two that he gave.
Oh, let's see. Look at how short this is, by the way.
It's just insane.
Look, see, he has the exact same thing again, except he changes like this, of course, but or maybe that is the same. Not too sure.
Yeah, he created a hash map. So you know what? Oh, no, that makes sense. Okay, yeah. So what you had to do for this, I don't know if a hash map was a good idea, by the way. I'll be honest, but basically that's how he's mapping. I think I could be wrong with this. Is that how he's mapping primes to their frequency?
I think put
We'd have
P and
to.
N. Yes.
Okay. Yeah, it's interesting because I wouldn't have done it like that. And to be honest, I actually think a better solution was what we saw from that other competitor.
With just parallel arrays.
Just using the parallel arrays. That seemed
Right.
like a really yeah. That seemed easier to me.
Mm-hmm.
Also, with a hash map, I feel like depending on the implementation, you also don't know how long the lookup time is going to be. I feel like with an array, you can be confident that the lookup time is like as fast as lookup time for any variable is. You know,
It's one thing I want to note. It's kind of funny that he did 10,000.
I know, but isn't that interesting?
It's
Do you
because
know
if
that?
you look at the solution, it says it's like you should have reached that 30,000 thing, but the actual max was like 3,000 something.
So how did he know that? Like
I don't
that
think
is
he did.
so.
I think he guessed. He might have just been like kind of like going up until it worked. Like maybe he started at 1,000 and then 2,000 and then five. No, then
Yeah,
he would
you
have
know what I
got it there.
wonder?
But
I
like
wonder if he recognized from the test at two that an upper bound could be created, and then he thought, oh, okay,
but the thing is,
um,
if you think about an upper bound, there's no way to like calculate 10,000. Like how would you just randomly get that number? Maybe it's because he measured like how kind of measured how long his would take and thought 10,000 is about as high as it can go in like a reasonable amount of time, or maybe he just
yeah,
it could be like an experience thing where he's ran into questions like this doing Google code jams before, and maybe this is something they do where it's like even though the estimate is high, it's actually a lot lower. So he's like, I'm gonna do 10,000 just so it'll run faster, or something like
maybe.
that.
am just shocked, honestly, because I think
I wouldn't even make it run faster, but yeah.
if I remember the code for or like the math required to have the understanding because basically the simple upper bound was 30,000, but the complicated upper bound was 3,025, which required a lot of understanding.
Mm-hmm.
And the fact that he picked 10,000, you're right. I wonder if 10,000 was a bit of a guess. Maybe he knew about the 30,000 and thought he could take it lower and it would still work. I'm not sure why he did that, to be honest, but
Yeah.
that's pretty interesting that he went for that.
Yeah. Very interesting, but
Yeah, and
it is
instead of
what
a
it is.
break, he just went for a return. He returned the moment
Oh,
which is basically the same thing though, right?
you know what I just realized too?
But
Well, actually, no, never mind. No, never mind.
all right,
Sorry,
let's
my mom
see.
came in.
I'm just like fascinated by some of these answers, honestly.
Yeah, very interesting.
Yeah.
But, I think we can kind of wrap that
Okay,
part
well,
up.
the next code jam for those who passed, for those who were successful to qualify on this round, congrats. And for those who are going on to next round, the date is in 15 days from now.
hmm And then I think
So what,
another
two
like
weeks from
15
now?
days or so for the next round. So in total, 4,500 people are going to move on to round two. So if you didn't get this one, you
Yep,
still got two more chances. But yeah,
yep.
so I think that's going to be all from us for
Pretty,
today. Catch us next week. We're going to have the U of M students who ranked 8th, highest at the university, highest in Canada for the NCNA
nice.
ICPC regionals. And have them on, kind of chat a bit, talk about them, talk about their backgrounds, and see some tips maybe from some good competitive programmers. But yeah, other than that, I think we can sign
Awesome. Well,
off.
then we'll see.
Yeah, go. You can go ahead.
Exactly. So we'll see everyone. Thank you for watching.
Peace.